Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll solve a problem on Venturimeter. In our previous lecture already, I have discussed regarding the theory part and the derivation of Venturimeter. So in this lecture, we'll solve a problem related to this Venturimeter only. So here I have taken a question. An oil of specific gravity 0.8 is flowing through a Venturimeter having inlet diameter 20 centimeter and throw diameter 10 centimeter. The oil-mercury differential manometer shows a reading of 25 centimeter. Calculate the discharge of oil through the horizontal Venturimeter and consider the CD equal to 0.98. So this is the question given. So first of all, let me write the data given in this question. So here the data given is, let's write down the data given here. Specific gravity oil. So specific gravity of oil equal to 0.8 and flowing through a Venturimeter inlet diameter is 20 centimeter. So inlet diameter we can write D1, or you can write dia of inlet, let D1 this is, and that's it, that is 20 centimeter, or we can write 0.2 meter. Any one thing we can keep it. If you want to continue with centimeter, you can continue all the things in centimeter, or if you want to change its unit to meter, then you can continue everything in into meter. And this is one liquid which is flowing through the Venturimeter. Okay, now if you remember, suppose this is the pipe is there, and in this pipe the liquid is flowing. Now the liquid what is flowing in this pipe, that is oil. Okay, and Venturimeter, we know that when you are connecting the Venturimeter in the pipe, okay, that manometer need to be kept in that, so that we can get the difference of pressure in that. And in the manometer we should have mercury content. Okay, so this is the flow is there, that is oil is which is flowing, and that is the specific gravity is 0.8, and the mercury which is connected in the, suppose this is the connection of this, this is our U2 manometer is there, and here actually we have some difference will come either this side or this side, some difference will there, like this is the content of mercury, this is the content of mercury, and the mercury difference will be there. When the flow will be there in the pipe, then we'll get a difference in the manometer. So that difference, oil and mercury differential manometer, so this difference shows the value of 25 centimeter. So that means we can write that is x equal to 25 centimeter. Okay, now calculate the discharge of oil through the horizontal Venturimeter. Consider CD. CD is the coefficient of discharge, that is 0.9, which is always less than 1. Okay, and throw diameter we can consider, that is A2, or that is means D2, that is 10 centimeter. So here by this diameter we can calculate the A1, and by this diameter we can calculate the A2. Okay, we know the formula, pi by 4 D1 square, and here it is similarly we can write pi by 4, this is D2 square. Okay, now here you can see one liquid is oil, another liquid you can consider here, this is another liquid in the sense which is present in the manometer, that is mercury. So we need to write the specific gravity of mercury, that is we know in general 13.6, and if you want to calculate the density of this, we can calculate, that is multiplied by 1000, so we'll get 13,600 kg per meter cube. Now for presently we can write this value. Now as we know the formula of this discharge, that is Q, we have derived the formula for the discharge of this Venturimeter. What we got, Q equal to CD, we got A1 A2. Of course, I have written the small a1, a2 in the previous our derivation. So same thing we can write. Here I have taken the capital one. That's why I'm writing the capital one, a1 and a2, and divided by root over of a1 square minus a2 square and this is root over of 2gh. This is the formula which we have derived for the Venturimeter discharge. Okay, so now we can see in this data CD is given to us, A1, A2 we can find out from here, and 2G constant value is there. Now H need to be identified here. Okay, so H is the height, or you can say the pressure head. Okay, the pressure head in the this Venturimeter. So that how we can calculate. For that also one formula is there. H equal to, actually we need to find out in this way, X into SH by SO minus 1. Okay, and this is SH and SO is nothing but SH is the specific gravity of the heavy liquid. Okay, specific gravity of the heavy liquid, and this is specific gravity of the oil, or you can write SL, or light liquid we can also write. But here heavy liquid is, we know that is mercury. So here X value given how much? 25. So that is 25 into SH. SH is nothing but 13.6 divided by SO. SO is nothing but, or SL, specific gravity of light liquid, that is 0.8. Just put the value of this and minus 1. Actually, this is the formula which was considered by this manometer, actually, like how to find out this H, the pressure head in the pipe. Okay, now here if you solve it, we will get here 13.6 by 0.8, near about it will be, point will be cancelled. 136 by 8 means we'll get 17 minus 1. So here you will get 25 into 16. So 16 means we'll get 250 plus 150, 400. So this is 400. This is centimeter. We have not converted into meter. So this is centimeter of oil. This is the H. Okay, now we need to find out this A1 and A2. So A1 we can calculate here, pi by 4 d square, d1 square, that is 400 here again. So because 20 into 20, so 400, this is 4 cancel, 100 into pi. So that is nothing but 314 will get. Okay, 314 centimeter square, I hope. And next one is pi by 4 d2 square. So d2 here also 100. So that is pi by 4. This is 10 into square. That is 100. So 4 it will be cancelled, 25 into 3.14. So that will be 25 into 3, 75. This is 14 into again 25. So near about 78 or something will come like that, because I'll take the approximate value of 73, suppose. Okay, so these are the two values. Now what we'll do, we'll got all this value. H value we got, A1, A2 value we got, just put in this equation. Now the discharge of this oil, we can write CD equal to 0.98 into A1, A2, A1 equal to, we can write the value here. This is 314. A point something will be there, some value that I'm ignoring, into A2. This is also some 78 point something will be there. So let me write 5. And this is in the denominator. Again, we need to write the A1 square. That is 314 square minus 78.5. This one we can give in bracket, root over of 2gh. 2 into 9.81. I need to write in the 981 because that was in a meter. Here I have converted into centimeter, and this is 400 H, what we got from the equation. Correct. Now we just need to solve this equation. That's it. No other thing is there. We can find out with the help of this calculator, because such a big equation is there. So what I'll do one by one thing. 314 into 78.5, 24,649 into 0.98, 2 24156. 24156 divided by, and one more thing, this is root over of 2gs also you can calculate. This is how much? 2 into 981 into 400. This is 7,84,800. Okay, now this need to be root over of this, so here get the function of root over. Okay, now directly put it this, so 885. Okay, so that one 885, some value 0.88 something is there. Okay, similarly here also we need to write next one, that is 314 square, that is 98956, I think 596. This is 596 and minus of this one. Just you need to multiply and subtract all the things that need to be done. You can do it easily also. 78.5 square 6162. 6162.25 suppose. Okay, now mostly you got it. Now what I'll do here, this one I'll do 9895. What is that value? 98596 minus 6162.2. This one the value root over of this 304. So 24156 divided by 304, yeah, into 885.8. So let's see how much it is coming. 24156 into 885.8 equal to this one divided by 304. Okay, so near about we are getting 70,386. Okay, so that one you can write 70,386 point some value, that is centimeter cube per second. So you can convert it into meter cube per second. So for that what you can write, or we can write in the liter. You can write in the liter also. So that will be divided by 1000. So you can get 70.386, that is liter per second. Because discharge we know that we can write in the terms of meter cube per second, or we can write in the liter per second. So this is the final answer of the discharge. 70 liter per second water oil should come out from the pipe. So I hope you understand how to solve the problem in the Venturimeter. The main thing is equation of this first one, this equation what we got in the Euler derivation. So this is one important thing, and this one another one, how to find out this head. Okay, this pressure head value H, this one. So that required to calculate. Okay, so I hope you understand. If you are having any kind of query regarding this, you can give a comment on the comment box. Thank you all.